According to the second fundamental theorem of calculus, the derivative and the integral cancel out, and x gets dropped in. So we have x cosine of x squared. So that's letter choice D. Taking the derivative of f prime of x, that'll be the derivative of the integral from pi to x of e to the 2t sine squared of 3t dt. Second fundamental theorem of calculus cancels out the integral and the derivative. So we have e to the 2x sine squared of 3x. Which is letter choice A. Since we're taking the derivative of an integral from a number to a number, those are both constants. And the derivative from integral from a to b of f of x dx is equal to a constant. So the problem is asking to get a derivative of a constant, and the derivative of a constant is 0. So we're using letter choice E. We need to take f prime of x, so take the derivative of the integral from 7 to x of t squared sine of t dt. And the derivative and integral cancel out according to the second fundamental theorem of calculus. We have x squared sine of x is capital F prime of x. And evaluating at 5 pi over 2. So we're placing 5 pi over 2 into f prime of x. And since it's a calculator question, using our calculator to get the answer of 61.685. To find g of x, since g of x is defined as 5 plus the integral from 6 to x of f of t dt, we're placing in the value of 6 in for g. So g of 6 is equal to 5 plus the integral from 6 to 6 of f of t dt. Integral from a number to itself is just going to be 0. So we have 5 plus 0, which is just 5. So g of 6 is 5. Then to get g prime of x, taking the derivative of 5 plus the integral from 6 to x of f of t dt. The derivative of 5 is going to be 0 because the derivative of a constant is 0. So we need the derivative with respect to x of the integral from 6 to x of f of t dt. By the second fundamental theorem of calculus, derivative and integral cancel out, so that's just f of x. So g prime of x is f of x. So to get g prime of 6, we just need f of 6, and f of 6 is from the graph. Looking at the value at 6 is 3. So g prime of 6 is equal to 3. G double prime of x is equal to the f prime of x. So g double prime of 6 is equal to f prime of 6. We just need the slope of f at 6. Since the problem says there's a horizontal tangent line at x is equal to 6 on the f graph, g double prime of 6 is equal to 0. Part B, we need to know on what intervals g is decreasing. When g is decreasing, that means g prime of x is less than 0. Or g prime of x is negative. Since we know from the previous part that g prime of x is equal to f of x, the question is just asking when is f of x negative, or when is f of x less than 0. So looking at the graph to find out when f of x is negative, g will be decreasing then on the interval from -3, including -3, to 0, not including 0, union from 12 till 15, not including 12, but including 15. The reason why is because g prime of x, which is equal to f of x, is less than 0 on those intervals. In part C, we're going to find when is g concave down. The graph of g is going to be concave down. Means that we're going to look at when g double prime is less than 0. Since in part A we figured out that g double prime of x is equal to f prime of x. The question is asking when is f prime of x less than 0? Or when is f prime of x negative? F prime of x is talking about the slopes of f. So the question is asking when are the slopes of f of x negative? So to look at the graph of f, just looking where you see negative slopes. So g will be concave down on the interval, looking for those negative slopes from 6 until 15. Because g double prime of x, which is equal to f prime of x, is less than 0 on that interval.